Let's see, did that start? Yes, it did start. So we're going to work on 3x3 systems of equations today. The goal of this section is just to practice setting them up. Afterwards, maybe we'll spend some time actually solving these things. But right now, we just want to set these things up. That's going to be the big part of the challenge. And to get started, I want to go down to this one because it's kind of a nice way to ease into solving these types of systems of equations, or at least setting them up, because they kind of done some of the work here for you. And I've done a little bit more for you here by kind of color coding things. Now, it's not a bad idea, but I don't often demonstrate it very well, to write down what each of your variables represent. So in this case, X is the number of calories in a Big Mac, Y is the number of calories in a small order of fries, and Z is the number of calories in a medium Coke. So if you're looking at things, there's three unknowns. There's an X, there's a Y, and a Z. Typically speaking, if you have three unknowns, to solve there, you have to have three equations. And in general, you have to have an equal number of equations for the number of unknowns if you hope to have a reasonable chance of solving. So all right, so we got X, Y, and Z. So those are our variables respectively. The first one says the total number of calories in a Big Mac hamburger, a small order of fries, and a medium Coke is 1,000. Wow, that's pretty eye-popping. We got 1,000 calories there. So the number here, the thing you should be looking at is that it says the total number. So that's your X plus Y plus Z. And to finish this equation off, what number should I write here? 1,000. Beautiful. The number of calories in a Big Mac is 270 more than in an order of small fries. So, okay. We got to think about that a little bit. X is the number of calories in a Big Mac, and that is, when you see the word is, oftentimes that relates to the word equal, or the symbol equals. So what we're saying here is X is 270 more than the number of calories in a small order of fries. So to turn that into an equation, that's going to be X is, or X equals, 270 more than Y. So 270 here. And last but not least, the number of calories in a small order of French fries is 20 more than in a medium Coke. What you're going to have to be careful of is the order that you put these things in. Once again, when the problem says the number of calories is, so that is telling you that you've got an equals sign. So this is 20 more than the number of calories in a medium Coke. So that's 20 more than Z. And there's your three equations and three unknowns. Nice, nice. So let's stick with the food example a little bit, and I will actually give extra credit for somebody who rewrites this one. I keep on looking at this problem all the time and looking back at it and going, I just got to rewrite that one. I really, really hate the lack of imagination in food A and food B and food C. I stole this off of your WebAssign homework, so, shame on me maybe, but in any case, what I'd like you to do is rewrite this so that you add some actual foods here. And instead of using 1 ounce, maybe you do 1 serving size. That's fine. And you can pick different minerals or vitamins, but rewrite this so that it's actually a little bit more interesting. Let's go with what we're stuck with here. So there's 1 ounce of each of the 3 foods. Has the vitamin and mineral content shown in the table. How many ounces of each must be used to provide exactly 16 milligrams of niacin, 9 milligrams of zinc, and 13 milligrams of vitamin C. So kind of some interesting choices there, but let's see if we can't set up a system of equations to help solve this. We're going to let A, B, and C represent the number of ounces of each that we need to get this RDA requirement that we're looking for. So let's see. We're looking for exactly 16 milligrams of niacin. Okay, 16 milligrams of niacin. Let's highlight that for the moment. Our niacin comes from right here. And that can give us an equation. Now the equation that it implies is that when we add up all the nutrients that we get from so many ounces of each of these food, that we're going to get 16 milligrams. So it's going to look like this. We get 1 milligram of niacin for each ounce of food A, 2 for each ounce of B, and 2 for each ounce of C. When I total that up, what should I end up with?
5. Oh, 16, sorry.
There you go, 16. That's what we're looking for, is some combination of A, B, and C that's going to add up to the 16 milligrams of niacin that we're looking for. All right, not so bad. How about we do one for zinc? How much zinc were we looking for?
9 milligrams.
9 milligrams of zinc. All right, so it's 9 milligrams of zinc. And feel free to kind of race ahead and write down this equation for yourself. In fact, there's 2 more equations, including this one that we need. Last one's going to come from milligrams of vitamin C. Marcus, what would the next equation be to go along with zinc?
1A plus 1B plus 1C.
Perfect. So 1A plus 1B plus 1C equals 9. Thank you so much. And we got one last one. Gavin, what are we looking for in terms of milligrams of vitamin C?
2A plus 1B plus 2C is equal to 13.
Perfect. So here's your vitamin C. So as you said, 2A plus 1B plus 2C, and that's equal to 13. Cool. And there's your system of equations. Right now in this section, I want to give you a lot of examples on how to set these things up. So right now we're just going to work on setting these things up. Later, after we finish this section, maybe we'll go back and take some practice on actually solving these things. And in section 12.4, we're going to learn some more techniques as to how to solve these things. As if you didn't have enough, we'll actually figure out other ways to solve this in section 12.5. But are we okay with the setup here? What I'm looking for right now is this system of equations. That's what we're looking for. Isaac? All right? Yeah? Okay. Okay. So the first couple examples worked out pretty nice. But in example B, we're a little bit more on our own. So definitely a little bit more of a math kind of feel for this one. The sum of the angles in any triangle is 180 degrees. In triangle ABC, A is 10 less than the sum of angles B and C. And angle C is 100 less than twice B. So we're going to have 3 unknowns. What do you want to call our unknowns? What would be a good choice here?
A, B, and C.
A, B, and C. Good. Now, what you have to do is you have to kind of parse through this and find things that imply different equations, like the sum of the angles in any triangle is 180, or that angle A is 10 less than the sum of angles B and C. And finally, angle C is 100 less than twice angle B. So they're giving us enough information to come up with a system of equations. Let's see how we can do on this. Let's start with this one in yellow here. That one's pretty friendly to start with. Joey, what can I write here?
Just A plus B plus C equals 180.
Perfect. A plus B plus C equals 180. Cool. Elizabeth, the next one's a little bit more challenging. Angle A is 10 less than the sum of angles B and C. What's that one going to look like?
10, oh wait, yeah. B plus C minus 10 equals A.
Yeah. Now, I'll write it down in a slightly different order, but it's the same thing. Angle A is, so A is 10 less than the sum of B and C. So you got B plus C minus 10. Now, when it comes to solving this, we're going to rearrange those terms a little bit and, do what we need to. But right now, we're just interested in coming up with the equations. So, are we okay with this equation? Angle A is 10 less than the sum of B and C. Do I really need the parentheses here? No, I just put it there for style points. All right, you don't really need them. Let's look at the last one. The last one says angle C is 100 less than twice B. So try and write this one down for yourself. I'll give you a few seconds on that one. If you're watching this at home, maybe pause the video. Try and write down that last equation. Kelly, got this one?
I got C equals 2B minus 100.
Perfect. C equals 2B minus 100. 2B minus 100. Now, when it comes time to solve these things, you might want to rewrite it as A plus B plus C equals 100. And then I'll move this to the other side and have A minus B plus or minus C equals negative 10. And moving that to the other side, I'll have negative 2B plus C equals negative 100. Now, I will accept this. This is fine, but just kind of giving you a FYI. When we start solving these things with some of the techniques we're going to use in the next section, then, it's helpful to have it in this form. Yes?
When you rewrote the equation, A plus B plus C, you wrote it as 100 instead of 180.
Oh, thank you. Thank you. That should be a 180. Yep. Okay. Anything else on the equations for B here? Now, a lot of times what I'll do on exams is I'll kind of separate these problems. I'll give you one problem where I just set it up. I'll give you another problem where I give you the equations and ask you to finish solving. So don't think that you're going to get away without solving some 3x3 system equations. I just separate them so that if you can't come up with these, you can still earn points by solving it. All right, an artist makes 3 types of ceramic statues, large, medium, and small. So right away, let's just give ourselves some variables. Let's do L, M, and S. You could use A, B, and C, X, Y, and Z, whatever. But my preference is to use variables that kind of reflect the problem. I think it helps me write down the system of equations. So he makes these 3 types of statues at a monthly cost of $1,150 for 210 statues. Those are both different little facts here that we're gonna have to put together. so we can come up with a system of equations. So I'll put those in different colors. The manufacturing costs for the three types are 7, 6, and 5 respectively. So, all right. What color ink do you think I should use on this one? Should I use yellow or should I use orange?
Orange.
Orange, because this is talking about the cost. So that's going to go together with the cost. If the statues sell for 20, 12, and 9 respectively, how many of each type should be made to produce $2,290 worth? So, all right, well, that's some more information here. Sell for 20, 12, and 9 respectively. We're going to earn 2,900 or 2,290 bucks. So let's see if we can't write down some equations for these things. And help each other out. Okay, that's one. We need 2 more. So there's 3 unknowns here. You're going to have to come up with 3 equations. That's going to be part of the equation. A little harder when you do it yourself, right? Let's look at this first thing here. The artist makes 210 statues. That represents an equation. What equation should I write there if I'm using L, M, and S?
All 3 of those equals 210.
All 3 of them equals 210. Well, how is that in terms of an equation? What should I write?
L plus M plus S equals 210.
Yeah, there you go. The number of statues, that is L plus M plus S, equals 210. Great, that's our first equation. 1 down, 2 to go. Now our other equation talks about the cost. So let's figure out the cost here. Okay, well, let's see. The equation that we're going to come up with for the cost kind of reminds me of what we did up here. We wanted to figure out how much vitamin C we had. It was, well, 2 milligrams from food A, 2A plus 1B plus 2C. You had to multiply, and then we added all those up, and that gave you 13 milligrams of vitamin C. We're going to have to do similar to figure out what our monthly cost is. What are the things that contribute to our monthly cost? How much does it take to make a large statue here?
$7.
$7. So what should I write here?
7L.
Yeah, 7L, thank you. 7L, and, all right, so 7L. All right, so 7L plus what else?
6M.
6M plus 5S. And what's that gonna equal? 1150. So we've got our cost, we've got the number of statues. There's one last thing we wanna kind of figure out, and that is our profit. So, or at least our revenue. I guess it's not profit, we have to subtract here to get the profit. So that's the last one. Isaac, can you help me out with that one? Where are we gonna get our revenue? I wanna make $2,290 out of all this.
Those are from all three.
Mm-hmm.
So just like the 7L plus 6M plus 5S.
That was for our cost.
20L.
There you go. 20L plus 12M plus 9S. Beautiful. And that's it. There you go. 3 equations, 3 unknowns. And we're pushing off the problem of actually finishing solving these things to the later to section 12.4. Are we okay with this one? There was a lot of hesitation as I walked around. So if there's something that's not so clear, Joey?
Would you add like minus 1150 to the last one? Like why don't you for that equation? Because wouldn't the revenue be a part of that? The cost of making a statue?
So, well, let's see, this is the revenue. If you wanna find the profit, then you would subtract the 1150.
Okay.
But right now, it's just the revenue, so there is nothing in this problem that asks about the profit.
I gotcha.
Yeah, but I appreciate the question. All right, let's flip things over and go to example E, the top 3 finishers in a hot dog eating contest. Well, I'll tell you what, we could do this one, or we could do this one, which I just wrote this morning right before a class. The top 3 finishers in Nathan's hot dog eating contest in 2023 were Joey Chestnut, somebody named Esper, and somebody else named Webb. They had a combined 165 hot dogs. That's a lot of hot dogs. Esper beat Webb by 2 hot dogs. Together, Esper and Webb ate 17 more hot dogs than Chestnut. Set up the system equations to solve. So, okay, let's see if we can't do this one. So a little bit of a bump up from, you know, a little bit more bland problem in example E. So once again, you're looking for three equations and 3 unknowns. Let's agree on some variables. Now, a lot of times when I write problems, I'll kind of hint at some variables that you can use. In this one, C, E, and W will be the number of hot dogs eaten by each contestant. So try and come up with 3 equations and 3 unknowns. What's Keno?
Knuff. Ken and Barbie.
I sounded it out, all right. Should have been a little more phonetic, I guess. The odds in Keno are really horrible. But the funny thing is, with Michigan Lottery's version, is that there's a huge variation in your chance of winning depending on how many numbers you pick. If you pick the 9 spot or the 10 spot, you're gonna lose 90% of the time. 4, if you're exactly right, 4 has the best odds. Take my statistics class and I'll help you out with some of those things. But 4 has the best odds. All right, are we making any progress on this one? Hold on, all right.
I only got the easiest one done.
What's that?
I only got the easiest one done.
It's okay, you know, I give a point for each equation. And then if you get all 3, then you get a bonus point, so it'd be like a 4-point problem. So, you know, coming up with even one equation, that's partial credit, and want to get those equations.
1, 2, 3, 4, 5, 6.
Let's start with the easiest equation. So the easiest equation is that the top 3 finishers ate 165 hot dogs, right? So what equation does that represent?
C plus E plus W.
Yeah, all 3 of them, C plus E plus W equals 165. So, all right, that's the first one. Esper beat Webb by 2 hot dogs. That sounds like another one.
equals W plus 2.
Yeah, thank you, Alan. E equals W plus 2. So 2 more than W gives you Esper. So E equals W plus 2. Beautiful. And finally, together, Esper and Webb ate 17 more hot dogs than Chestnut. So there's a couple ways you could write this one, but let's see here. Esper and Webb together ate 17 more than Chestnut. So, got anything on that one?
E plus W equals 17 plus C.
Nice, well done. So their total is 17 more than Chestnut. So let's write that down. We've got E plus W is 17 more than Chestnut. So that's the last equation there. We can rearrange it, kind of like we did with this one, to put all the variables on one side, but that's your system of equations.
Is it easier to have all the variables on one side, like the first one, or do we wanna have the variables split up?
Well, I guess it depends on exactly how you're gonna solve this, but in general, not necessarily specifically, in general, it's probably nicer to have things on one side. So that I would write this as E minus W equals 2, and then move the C to the other side, minus C plus E plus W equals 17. So that's how I'd probably write it. And that's gonna be a convenient form to have it in when we start solving these types of equations with matrices. We'll use an augmented matrix to look at these things. We'll also use the inverse matrix. So, yeah. But as far as the test is concerned, at least get those 3 systems of equations, or those 3 equations for this one.
Would you be fine if we wrote the one on the left?
Yeah, yes, absolutely. You know, you write the equation on the left, my inner child will be doing somersaults. I'll be really happy. So, cool. And in case you're curious here, let's actually look up the results. There you go.
62.
Joey Chestnut, 62. I don't know how long they take. I don't know how long they take to get.
Hopefully years.
Maybe 10 minutes.
Yeah, that's probably more hot dogs that I've eaten in quite a few years.
I wouldn't know.
Yeah.
How are
So-
the percentages? Like number 7 has 29.75 hot dogs eaten.
Yeah, that's kind of an interesting observation. I don't know.
33.5.
Yeah. Yeah, I actually saw it on TV one time. I just caught the end and no thanks. I mean, they actually dip their hot dog buns in water so that they can chuck them down faster. Yeah. Anyways, let's move on. Let's move on. Let's move on down to F. Now, this was true as of the writing of this problem, I think last fall, or maybe it was last winter. I looked these up and wrote another problem just to try and make it a little bit more interesting. The top 3 most popular television shows of all time: Game of Thrones, Stranger Things, and Walking Dead. So let's come up with some, I don't know, you can use A, B, and C, or we can use G, S, and W. What variables do you want to use? G, S, and W? All right. GSW sounds like gunshot wound. All right, G, S, and W. Again, trying to come up with 3 equations. The first one should be a little bit easier than the next 2, but try and come up with those 3 equations. If you're watching this at home, pause the video, try and find those yourself, and then double check yourself. Okay. Let's see. Total number of episodes of these 3 shows is 581. That one should be a pretty straightforward. So that's going to be G plus W plus, well, I should write it in order, I suppose. G plus S plus W. G plus, that actually worked. I was kind of surprised. G plus S plus W equals 581. There are 27 more episodes of A than C. So 27 more episodes of Game of Thrones than Walking Dead. Kind of surprised Walking Dead has that many. All right, so what would that be in terms of an equation?
G equals 27 plus W.
Or A
So-
minus C equals 27.
You can do A, if you're doing A and C, you can do A equals C plus 27, or you can do A minus 27 equals C. They're both the same. If I'm using G, S, and W, then Game of Thrones, G would equal 27 plus C. And one last one. let's see, the difference between the number of episodes of B and C is 11. So that's between B and C. They'd be Stranger Things and Walking Dead. So S minus W equals 11. You could also do this in A, B, and C. If you're doing this in A, B, and C, it'd be A plus B plus C equals 581. And then, let's see, I mixed things up here, didn't I? It shouldn't be a C. That should be a W. So this one would be A equals 27 plus C, and the last one would be B minus W equals 11. So you can write it in either one of those, A, B, and C, or G, S, and W. Any preference for one versus the other? First one versus the second one? No?
Depends how we solve them.
You're gonna solve them the same way. You're gonna move everything to the left-hand side, and then we'll use something called Gaussian elimination, not a term you need to know. But moving everything to the left-hand side like we did with the last one is probably where we're gonna go. Let's finish up with some top-selling artists of all time, top-selling record artists. According to Statista, the top 3 selling artists based on certified sales are the Beatles, Garth Brooks, and Elvis Presley. So we'll just use A, B, and C, respectively. A, B, and C. I probably shouldn't be putting these in different colors because I'm going to save that for something else. The 3 artists have sold 479 million albums. That's a lot of albums. Combined, Garth Brooks and Elvis have 113 million more than the Beatles. Twice the number of Elvis records is 95 million more than the albums the Beatles sold. All right, so 3 different things there. Do you want to take your shot at it? A, B, and C. Try and figure that out. Okay. Let's have at it. Mateo, I'll give you the first one.
A plus B plus C equals 479 million.
Yeah, we're just gonna leave it in units of millions, so 479. Perfect, thank you. Silas, how about this one? Garth Brooks and Elvis have sold 113 more million than the Beatles.
I wrote B plus C equals A plus 113.
Yeah. 113. Perfect. Garth Brooks plus Elvis have 113 million more than the Beatles. Awesome. Awesome. I need one last equation. Brady. Twice the number of Elvis records is 95 million more than the albums the Beatles have sold.
2C equals 95 plus A.
Nice. 95 plus A. Great. And move things around as needed to finish solving. So perfect. Perfect. Comments or thoughts on this last one or any of these things? All right, let's put this one in the books.